எப்படி வரான் போவாங்கடா பையன் மாட்டான்
யார்கிட்ட ஃபோன்
வச்சுட்டு கிளாரிட்டி இருந்தா என் ஃபோன் லென்ஸ் ஆடிச்சு லென்ஸ் தெரியல மாதிரி ஜூம் பண்ணால் கிளாரிட்டியே போகுதுண்ணா என்னன்னு தெரியல
யார் பக்காவாக செட் பண்ணுது ஆமாம்
யார் செட் பண்ணாங்க
சரிண்ணா அது நல்லா தான் இருந்துச்சு
இல்லை கேமரா குவாலிட்டி
ஓகே இருக்கு இது சென்னை இங்கே தானே
கை காட்டிட்டு இருக்காதவா இங்கே தான்
நான் தான் நான் தான் ஆன்
எந்திர பாலமுருகன் எந்திரு நற்குணன் நெக்ஸ்ட் இங்க வந்துடுடா
லைவ்ல போயிட்டு இருக்கு கரண்ட் மாட்டானா
மேடம் தேர்ட் இயர் எல்லாம் வந்துட்டா
external participant new students யாரும் வந்திருக்கீங்களா சென்டென்ஸ்
ஹலோ
சவுண்ட் கேட்கும் போர்டு என்ன தெரியாதா
Welcome to Krishnasamy College of Engineering and Technology. Electrical and electronics innovates. Energy evolves. The future. Welcome to Krishnasamy College of Engineering and Technology. Electrical and electronics innovates. Energy evolves.
இதே ஒய்ஃபை இல்லை டிஸ்கனெக்ட் தான் வருது.
J. Kumar sir to introduce our resource Professor Dr. Kumar Krishnasamy, Associate Professor in the School of Computer and Electrical Engineering, Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, Chennai.
So it is indeed a great honor and privilege for us to welcome our distinguished guest, Professor Dr. Kumar Krishnasamy, Associate Professor in the School of Computer and Electrical Engineering, Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, Chennai. Professor Dr. Kumar Krishnasamy obtained his bachelor degree in Electrical Electronics Engineering in the year 2006 from Coimbatore Institute of Technology, Coimbatore. He secured All India rank 358 in GATE exam and obtained his M.Tech degree in Power System from National Institute of Technology, Tiruchirappalli, Tamil Nadu, India. 2009, further he was a postdoctoral research fellow in Nanyang Technological University, Singapore, from November 2012 to 2013. So he is an awardee of Power System Operation Control for doctoral degree, and he listed his PhD dissertation in top 10 among all IITs and NITs in the year 2014. The award is given by Power System Operation Corporation, Power Grid Corporation of India Limited in partnership with the Foundation for Innovation and Technology Transfer, IIT Delhi. Professor Dr. Kumar was an associate professor School of Computer and Electrical Engineering, Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, Chennai. He was an assistant professor in the Department of Electrical Engineering, Malavia National Institute of Technology, Jaipur, Rajasthan, India in the year of 2013 to 2018. He also holds the adjunct faculty position at National Center for Disaster Mitigation and Management, MNIT, Jaipur. He received Young Scientist Award for the Startup Research Grant, which was given by SERB DST in the year 2015. He is also the Young Faculty Fellow of Ministry of Communication and Information Technology since 2016. He was a visiting professor at the University of Saskatchewan, Canada, and Fellow of Indian-Canadian Shastri Institute. With immense respect and pleasure, let us warmly welcome Professor Dr. Sivaramakrishnan and being with us today to knowledge expertise. Sir, we truly honored to have you with us. We looking forward to an enlightenment and inspiring session. Thank you, sir.
Thank you for the wonderful introduction.
Now we invite our expert resource person, Professor Dr. Krishnasamy, Associate Professor in the School of Computer and Electrical Engineering, Indian Institute of Information and Technology, Design and Manufacturing, Kanjipuram, to lead us into the technical seminar section.
So, as a token of interest, so we have to give an memento and shield for us for the staff. Thank you, sir.
So, good afternoon all. It's a great pleasure to be here as a resource person in this seminar that is sponsored by CSIR on various electronic storage and energy harvesting techniques for EVs and wearables, right? So on today's talk, I'm going to discuss on smart energy technologies. So just I would like to thank that management and organizing secretary of this workshop for that invitation. It's my pleasure to discuss this topic among you all. So when we talk about smart energy technologies, so here if we talk about smart energy technologies, we talk about electronics, even about renewable energy systems. So all are, you can say, energy technologies. Now how the smartness come into the picture means, once you are establishing the communication among the various devices in the system, then your device is going to be smarter. So that's what we are saying is a smart energy technologies. So how our system can be smarter, so that we can discuss in this in today's talk. So before going to that, just I would like to introduce that energy transformation by 2050. It's not moving. Oh yeah, it's moving. Yeah, sure. That's right. So going back to smart energy technologies, just for any industry or any research institute, people will talk about sustainable development goals. So that is the SDG. So just you can say any institute or any organization you can go, they will talk about the SDGs. So when we come into that energy technology, we will talk about SDG 7, that is affordable and clean energy, and we have the sustainable cities and communities. So in these two, as electrical engineers, we can, electrical or electronics engineer, we can able to contribute in this sustainable development goals. So by looking into the various renewable energy resources, we can able to achieve this SDG 7, that is affordable and clean energy. And when we come into that EV, or you can you might have IoT, application of IoT into the energy systems. So the reason for exploring that IoT technology is to make your system smarter, whether it's the energy systems or you can talk about any kind of services. So for those things, just we can be able to achieve the SDG 7. So that's what just we can leveraging this IoT, or we can talk about machine learnings, or we can talk about artificial intelligence. So those and all can explore to achieve the sustainable cities and communities, as well as the affordable and clean energy technologies. So we can look into that how the world's demand, or we can say the investment is happening in the different sectors. So earlier, if you can see that this side in 2015, just you can see that the huge investment in oil energy sector. So we can say it's almost 18 billion USD dollars. Then when we come into the natural gas, then just the investment is huge next to this oil and energy. Then renewables, right? So the renewables in the third place in 2015. So then grids and storage, then energy efficiency is 302 billion US dollar. But when we come to the 2025, we can see that the world investment is happening in the renewable energy sector. In addition, then just the oil and sector also is getting the same attention, and the grids and storage. So here you can see that there is a huge shift happening in the investment perspective towards the energy sector. So that's what we can able to evident from this stats, right? So here the transformation. So in 2050, how the energy transformation is happening. So the main objective of this energy transformation is to reduce the carbon emissions. So even we can see that the huge amount of the demand going to meet out by the conventional energy sources like thermal power plants, or just you can say it's hydropower plants, right? So by introducing that new renewable energy sources, we can able to reduce the carbon emission from the present level of 70%. Then at the same time, the energy cost also is coming down. If you can see that 2 decades before, if you want to generate that 1 unit of PV, then just you need to spend at least 15 to 20 rupees per unit. Now, what is the cost of 1 unit of renewable energy? If you are generating the power from the wind or photovoltaic systems, so what is the cost? Do you have any idea? So even in India, we are having a separate ministry. How many of you are aware of it for renewable energy? Yes, Ministry of New Renewable Energy. So we'll call it as MNRE, right? So in this MNRE website, if you go and look into the statistics, you can get to know that even the price of this PV power or wind power, they are bidding for 2 rupees, right? So you are getting the 2 rupees per unit. But whatever the price we are getting in our residential or commercial, that's a different, because the utilities, they will buy from this producers, then they have the service charge and other things, then they are selling the power at 5 rupees per unit, right? It's a rooftop photovoltaic systems in our residence as well as the commercial buildings. So how many of you, anyone of you having the rooftop PV on the rooftop? Or it's not required. Do you have any idea what is the 1 kilowatt of the PV if you want to install, how much they are charging? The vendors? Any guess? Any rough idea on that? Yes, aware of it? For 1 kilowatt of PV if you want to install on the roof. So how much they are charging? Sorry? 40,000. Yeah, sure. 40,000 is the minimal. So it's around 50 to 60,000 they are charging. Very good. So here we can say that suppose if you want to install that 5 kilowatt, almost it requires 3 lakhs rupees. So by looking at that initial investment, that's a huge. But if you look at that lifetime of that photovoltaic system, that's a 20 years. So within a 5 years period of time, whatever the money you have invested for that, we can get back. Then for the consumer. So that's what we can say that will provide the greater economic gain. And another thing, another objective is to enhance the energy security of the country or any nation, we can say. So how we can enhance the energy security? Because you know some war is happening now, right? So between which countries? War போயிட்டு இருக்குல்ல எந்த கண்ட்ரிக்கு இப்ப Iran versus, it's not a match, it's a war, right? Iran versus and US. So I mean US is supporting the Israel, so that's what war happening between them. So in the war nala enna prachana? What's the problem? Oil crisis? Yes. So how we learn that oil or because of that, so this is called the energy crisis, right? So oil crisis, oil also is a kind of energy. So because in our country we are having the thermal power plants, all the thermal power plants they are burning the coal and oil. So then only you can able to produce the steam. Then that steam can be used to rotate your turbine. So that turbine can be connected with the generator produces steam. So here in any countries, then we will be in the greater demand of these resources. So if it's happening, then what will happen? So just we will not get the coal to burn to produce the steam. So that time I might not get electricity, so I need to get a 4 hours or 8 hours power cut. This was happened during 2010, I guess. I don't know how many of you have realized that. So even there are 4 hours or 8 hours power cut in some of the areas in Tamil Nadu. So that's what we can say. If you are having your own generation of power, so you need not to depending upon any other countries. So that's what you can enhance the energy security by going with the wind and photovoltaic systems. So that's what the enhancing the energy security and energy access. Full energy access means even we can say is 3 to 4% of the locations in India are far away from the distribution networks. So in those areas you cannot able to produce, you cannot able to supply the power, electrical power. So in those areas just we can generate the power by using the wind and photovoltaic systems, right? So that's what we can say. In any country, if you say you can able to have the 100% energy access. So on top of all, you can say in terms of techno-economic perspective, we can able to create a lot of job opportunities on this alternative energy sources. So this was a renewable energy estimation. You can look at that. In 2050, we need almost 55,000 terawatt hours of the energy is required per year. So in this 55,000 terawatt hours of the energy, you can see that 86% of the energy produced by renewable energy. This 6%, if you can see that, then almost 6,000 gigawatt of the power from the wind energy conversion system and another 8,500 odd gigawatt of the power from the photovoltaic systems, right? So these two, wind and PV can contribute in the huge demand, or we can say that that's going to supply the huge supply, right? So the energy efficiency of the premise here. Energy is the renewable resources. So in the bottom of the pyramid, you need not to spend any money or any capital is required for the bottom of the pyramid. Energy conservation means is depending upon the usage pattern of the appliances. For example, if you are saying that whenever you are not using the fan and AC, please switch it off. So this is called the energy conservative measures. So for this you need any investment? You need not to require any investment, right? So that's what the energy conservation also is one of the very important point in the energy pyramid. And in the second stage, you can say is the energy efficiency. So what is energy efficiency? Energy efficient equipment. So how do I say my equipment or my gadgets or appliances star rating, or you can use a 3-star air conditioner, you can use the 5-star air conditioner, right? So here in a lighting, instead of using the incandescent, we shifted to the fluorescent lamps. Then now LED lights, right? So wherever we can see that we are having the LED lights. So these are all the energy efficient devices. So if you are having existing devices, lights or fans, you are replacing them with the energy efficient gadgets or devices, right? So in this case, whether you need an investment or not, yes, I need an investment because I need to buy this energy efficient devices and I have to replace them, right? So for that we need an investment. That investment is higher than this energy conservation. On top of this, we are having the renewable energy sources. So the investment for the renewable energy is more than the efficient devices. What in the pyramid, if you are going from the bottom to top, the complexity and cost will increase. Another energy harvesting method, it's a wind energy conversion system. So in the wind energy conversion system also, just we are having the turbines in 1980 itself. So they had some small turbines, 50 kilowatt and in a kilowatt range. So when the year goes up, you can see that even in a single wind turbine having the capacity of 14 megawatt, right? So when the year keep on increasing, a single wind turbine capacity. At the same time, if you look at that, when the year increases, the capacity of the wind turbine increases. When the capacity increases, what's happening with the wind turbine blades? Or you can say that area also keep on increasing. That's what the circles are keep on increasing. You can see. So that means that the length of the blades keep on increasing, so that the area also increasing. Right? So in the wind energy system, you can see that how the electronics plays a role in the harvesting the wind power. So you can see that till 1995 there is no power electronic converters involved. So you can see that 0% converter rating. So there is no converters, power electronic converters. So the power electronics or power electronics means it's the same. I think you have the mixture of EC and electrical people, right? So what is the difference between the electronic devices and power electronics? The same BJT you might have studied there. Here you will study the power BJT. So there you have studied the diode. Here it's a power diode. So only the characteristics of that diode will change. Only we can say that peak inverse voltage and the feed forward voltage change. The different characteristics. Here using also is a semiconductor device, and the power diode or thyristors, IGBTs or MOSFETs. These are also is a semiconductor devices. So here that is getting popular in the year of 1995. Even it's getting very popular in 2010. Why the people are afraid to use the power of the 14 megawatt, right? So here you can see that these are the strategies. So how controlling the generator. starter to start that wind turbine and you are bypassing it. Then later on to control the speed of the machine for implementing the maximum power point tracking, they can use that rotor resistance control and rotor power control. Rotor power control means it's a DFIG based machines. I'll discuss with you why we are calling the DFIG and the WRIG systems. And the generator power control. So whatever the generator you are using in the wind turbines, so that is there you are having the generator power control. That means you are controlling the generator output by controlling the speed of the machine. That's the indirect power control. That means that if I want to implement the maximum power point tracking algorithms, then you have to go with this. So here the photovoltaic system, there is no rotational parts, only the static part. So just you are having the PV panels, just you can lay down on the roof of the buildings. But is it possible to have the wind turbine on the roof of our buildings? It's not possible. Even if I wanted 10 watts or 100 watts also, I can able to generate from the PV panel, but I could not able to generate from the wind turbines. So the easy installation because of the static parts. So that's what the solar photovoltaic systems keep on increasing. At the same time, just we can say installation is very easy. Even I can buy the panels and inverters and I can assemble and I can use it for a home. But wind is not in that way. So even rotational parts. So next, when we are moving to the smart grid. So it's very interesting topic. When we say, how many of you are from electrical engineering background? Please raise your hand. All are from electrical engineering? All triple. Then it's very easy for me, to explain it. Yes. Okay. Now the question for you is, what's the difference between the smart grid and the grid? Is if I say it's a smart grid is a new grid. Do you have any idea? Smart grid? Yes. What we are doing is we are adding the features into the existing grid. The grid is already existing, and what we are doing is just we are integrating the smartness. So how we are integrating the smartness into the smartness? We are doing the communication protocols and communication methods, whether it's a wired or wireless communication. Then just you are deploying a lot of sensors to sensing the data. Once you are sensing the data, then just you have to transmit the data to that to the server, local server or main server. So how we are communicating? Through the sensors, and that's a transmission line. Then you are having the distribution lines, primary distribution. The power and flow from the generator to the load. So there is no bidirectional power flow. At the same time, there is no communication among the generation, transmission, distribution and loads. These are not isolated. But here you can see that you are having the communication among all the devices. So once you are communicating among all the devices, just you are integrating the smartness into the various components in the system, right? So that's what just you are creating the you are establishing the communication among the various devices or various systems, you can say. So here it's a conventional power generation plants. Then you are having the transmission lines, you are transmitting, and you are having the distribution. So you are distributing to the loads. Now my question is, you are having the photovoltaic panel on the roof, or you are having the wind energy conversion systems. So where connect the photovoltaic? Any idea or any guess? Where we are integrating? Integrating means where we are pumping our solar photovoltaic power into the distribution or into the transmission or in the generation. You are generating the power in the PV panel on a rooftop. Yes or no? Yes. Right. So once you are generating, and where we are feeding, where we are connecting our PV power to the distribution, transmission, or yes, to the local grid. So local grid means it's a distribution. So that's what now we are calling this wind and photovoltaic system as a distributed generation sources, right? DGs, distributed generation sources. The reason is we are adding this wind and photovoltaic into the distribution networks, right? So what are the disadvantages by adding this wind and photovoltaic distribution networks? Create stability issues. Why the stability issues and harmonics into the system? Because more power converters. Okay, that's a reason for harmonics. Then stability, climate change. No, the case is here when we talk about that wind velocity or solar irradiance, whether it's a constant. Is it possible for me to control the wind velocity or irradiance? So I cannot control the sun, right? So if you can able to do it, you are the God for everything, right? So we cannot able to control. That means that the resource or input is not controllable. That means that we will get the intermediate power from the system. What is a lot of system. So we can talk about the power quality, or if you talk about the stability or harmonics, everything can be included in that. So how we can mitigate or how we can avoid it? By using the filters, electric passive filters, so we can reduce the harmonics. But stability I cannot with the filters. Yeah, again we are adding the devices into the system. So stability, in terms of energy perspective, here I am getting the various the power output from the wind and photovoltaic system is keep on changing. Suppose now I am having the photovoltaic system on the roof and I am connecting these loads. So what happens when the irradiance is there, my light on, then if the irradiance will keep on change, what will happen? My lights or fans will flicker. What's the reason? Then you have to match the supply and demand, right? So my demand, my loads are 5 kilowatt, then your power output from the PV also should be 5 kilowatt and more. If it goes below 5 kilowatt, it's a 4 kilowatt, my load is 5 kilowatt, so how we can adjust, how we can manage? No, boosting the voltage, not, that's a boosting the voltage. That's boosting the voltage. It will not give a power. It will not boost up the power. Yes. Yeah. It's a the energy storage huge. So only we have to bring the battery storage or any kind of energy storage, supercapacitors, or you can bring any flywheel energy storage. So that what will happen? So whenever you are having the excess power, that excess power can be used to store it in the battery, and only the demand will be matched up. So when the demand is higher, then supply is lower, then this and this will match the demand, right? So that's what the energy storage, integration of the energy storage also it's important in the when we are talking about the wind and photovoltaic systems, right? So that's what people will add, that energy storage, that means battery energy storage along with this renewable energy sources. Okay, this part is very interesting part, the load side, right? So as a load, if you talk about the load side, we are the loads. So we are in the home, we can talk about your home or the commercial buildings, loads. What are the advancements at the load side? This is very interesting to investigate. Nowadays, we are simply, earlier days they used to say we are the consumers, right? We are the consumers. I mean, consumers means loads. We are consuming. That's what we are. They named it as the consumers, right? So, but power, we are consuming the energy, right? Because we are only the loads we had, right? So nowadays we have had only the loads. Even in my home or my institute, no, I rooftop heat, right? Rooftop heat. We are generating the power. We are the producers. So what's it called? We are producers now. So producers and consumers. Then you can call us as prosumers. Now, if you see that some of the research papers or if you study the smart grid, so no more the consumer name is there. So we are the prosumers. Prosumer means we are having the producing that energy as well as consuming energy. That's what they named as the prosumers, right? So we are prosumers, right? So we are the prosumers. So we can see that what are the developments is happening. So when we talk about the factories, so what technology as engineer, what's going on in the factories? Have you heard the automation, the robotics, or you can talk about the industry 4.0 or 5.0? You have the name. These are the fancy names. Normally the mechanical engineers use, mechanical effects engineers use the industry 4.0 means that. Any idea? Because your topic is on future electronics, so that's what just I want to touch upon that, developments also. Yeah, smart houses. So how we can say our houses become smarter? By using IoT. Very good. So the best example I want to share it with you. Actually, it's a 6 months back. Just I bought a house. So for that house, I plan to put an air conditioner. So with my wife, so I go with this air conditioners for the house. Yes, we agreed that. Then we had a discussion. So which air conditioner we can buy? So how do you buy the air conditioner for a house or for a individual? Any idea? So don't ask. That's your personal problem. So why you are sharing that personal problem with us, right? It's not a case. Just I want to convey something here, right? Yes. Yeah. Now just we can say that based on the room size, we have to decide what's the tonnage of the air conditioner is required. Good. Whether I can go for 1.5 ton or 2 ton or 1 ton AC, right? Then thereafter, yes, inverter based AC. I'll come to 1.5. Otherwise, you will air conditioner. So what is the difference between that conventional air conditioners and inverter air conditioners? Any idea? What's the difference between the conventional earlier air conditioners with the 3-star, 5-star? Now we are having the inverter air conditioners. So even if you go to the shop, shopkeeper used to say, sir, go with the inverter air conditioners. If you are buying the inverter air conditioners, the lifetime of the inverter air conditioners are more than the conventional air conditioners. So how he is claiming that? Regulated power, for that I can use stabilizers. So why I need to go for inverter then? In the room. So he is saying that, okay, come to the another point is, so how he is saying that the lifetime of that inverter AC is more than the conventional air conditioners? Any guess? Yes, that will take care of it. Even if you are having the voltage fluctuation, yeah, that will absorb and that will run the air conditioners. That's good. Even you can say that that will operate from 150 volt to 220 volt. You need not to connect the stabilizers. Earlier conventional air conditioners, you need to connect the stabilizers. Right now it's not required for the inverter ACs. Right, good. But how the lifetime? Okay, I'll put one more example. So now you are having the switch, right? So no switch, go down. So how do you design the lifetime of your switch of the fans and lights using the switches, right? So how do you design the lifetime of the switch? Number of on and off cycles. Very good. Number of on and off cycles. So if I say a particular company, you are having 1 lakh times of on and off. If you are going Legrand or GM, then I can say it's 5 lakhs times of on and off. Right. Good. So the same earlier cases, you can see that if you are having the air conditioners, if you set the 25 degrees centigrade, so when the temperature goes below it, then your air off. Your air conditioner off. Then when the temperature goes above it, 25 means if it goes 26, then your air conditioner on, right? So have you seen that on and off of your compressor in your air conditioner depending upon the set temperature? Yes. But now if you see that inverter air conditioners will keep on running. So there is no can in the then your motor. So when the temperature goes below it that you are slowing down that compressor, then when the temperature goes above that set temperature, then your compressor speed will be higher. So you are not doing any on and off of the compressor. That's what he is saying, that salesperson used to say that lifetime of the inverter air conditioners are higher, right? Yes. Okay, that's one case. That's the inverter air. Nowadays there is an option also available. Have you seen that? Even if you can have the Amazon or Flipkart, you can search at air conditioner. So they have two variants. Have you observed it? Huh? Have you observed it? What is the other option we are having? Yes? Huh? Non-inverter. Oh, non-inverter, inverter we discussed. On top of it, inverter. Then after inverter, this technology is now overtaken by another two variants. Have you heard the Wi-Fi and non-Wi-Fi? Wi-Fi and non-Wi-Fi? Yes, used to say that all people have used to watch the air conditioner. So what that air conditioner does, wherever you can move, that air conditioner will flow the air towards the person. So how it possible? How the air conditioner, if you are having the fan in the air conditioner, so when I move here, your air flow will be in this direction. So when I go back, the air flow will come into the direction. So how this air conditioner observe me and changing the airflow direction? Is the sensors, right? Is the sensors. So the sensor, what you need to do? You need a communication. So that's why connecting your air conditioner with the Wi-Fi, right? So you are connecting to the internet. So if I am connecting to the internet, what is the advantage I am getting? It's the Wi-Fi air conditioners. If my mobile is there, if I am not having my Wi-Fi or internet, is this useful now? Nowadays, at present, no use, right? Even I need not to buy this smartphone. I might use that basic phone, right? Yes. So the same, if you are having the Wi-Fi air conditioners, if you are connecting that air conditioner to the internet, that means Wi-Fi router. So what is the advantage you are getting? Yeah, you can control anywhere. So that's what I know. If you are going with a Wi-Fi air conditioner, the price is 15,000 extra, 15,000 or 20,000 extra. So if I say 1.5 ton, non-Wi-Fi means certain rupees, Wi-Fi means 1,000 rupees. So the same debate happened. So I come to the personal issue now. So I say that I told her that okay, I can go for Wi-Fi air conditioner. So 50,000. Then she asked, why you are going 50,000 air conditioner? You can go with 35,000 air conditioner without Wi-Fi. The same cooling I am getting. Then why 15,000 you need to spend extra for Wi-Fi air conditioner? So how do I convince my wife to go for Wi-Fi air conditioner? So we are not giving ideas, so we have to find the solution like that you want to say. The thing is that very simple. And now we are having the fixed tariff. So fixed tariff, there is no use of it. But if you are considering the variable tariff, that price will keep on change. Even in time the so during morning hours or evening hours, the electricity price is higher. So during afternoon and night time, the electricity price will be lower. So it will be useful means whenever you are having the time of use tariff. So what is the time of use tariff? I think in electrical engineer we must know that. Even in our TNEB, we are using electricity as a commodity. So tariff. So how many of you have used Uber, Ola or Rapido? Uber, Ola and all, have you heard Uber, Ola, Rapido? Yes, Ogis. Right? So how the price is happening? Suppose for morning I want to move from this place to, you can say it's a Banrutti or Viluppuram. The morning the price might be a 1. Then afternoon the price might be lesser. Even in evening or night time, if you see that the prices are higher. The afternoon the prices are lower. Why? What's the reason? The peak hour. For that you need to connect your air conditioner with the Wi-Fi network. So their algorithm will take care that observe the price changes. Then you can adjust the temperature. So what is the use of adjusting the temperature? By adjusting the temperature, you can able to reduce your electricity bill, right? You can able to reduce your electricity bill. So this is called in power system research, they used to call as a demand response management, right? If you are saying it's a demand, based on the demand, you are adjusting the loads, right? So you might have studied in your higher semesters, demand response management in power system operation and control, I guess, right? So this called it's a demand response management, DRM. For DRM only we are connecting our to the internet. So that's what I think that our how becoming a smarter. So why we are calling as a smarter means I'm connecting all my gadgets, devices into the internet, right? Yes. So the same, it's happening in the commercial buildings also. Just all the devices, or you are having the surveillance cameras, everything can be connected to the internet. So that if you are connecting to the internet, that you are sending all these things into the cloud, and you are doing the cloud computing, and you are saying that how much energy you are using, or that can predict how much energy you are going to use in the future. And that will, if you are integrating your surveillance camera also to the cloud computation, then there you can use the image processing and all. Then you can say that any intruder enter into the house, if the intruder enter into the house, that will give the alarm or call, everything. So this kind of things normally we will do it in the internet office. So that we are communication, all the communication protocol systems into the building. So normally in a research we used to call it as a home energy management system or building energy management system, right? So then another thing is EVs. So EVs also, I'm having some very good story. I think it's time for you, the time will not enough to cover it up like this. So EVs is very interesting thing. Why I'm saying that, whatever the EVs nowadays we are using as a mobile. Why I am saying we are using the EV as a mobile? Any guess? Just we are charging it and we are driving it. Again, just we are discharging the battery. Again, we are coming and charging it and we are leaving. So it's a kind of unidirectional charge. But here in the EVs, we are having the batteries. So once we are having the battery, we are converting to the EVs, and you can get the very good energy storage capacity. So that capacity, energy storage capacity, control strategies. So here, when we say it's the intelligent control strategies, then people will, leveraging that artificial intelligence or machine learning models for, for designing these controllers. So that's what now we are saying is the intelligent control. The people might ask that, why that power electronic converter is required between that PV and wind and the power grid. So if you want to control the power and implement the maximum power point tracking algorithms, you need this kind of power electronic converters. So for that, the reactive power can be taken from the grid and the real power can be flow from machine to grid. So here always take the reactive power from the grid. That's what at this point of common coupling we used to say. So in the point of common coupling, just the power factor is poor. So to enhance the power factor at the point of common coupling, you have to integrate the capacitor banks here, right? So here, if you want to make this indexing machine as a generator, you always need to rotate above synchronous speed, right? So if I say it's 50 hertz 4-pole machine having, then the speed is 1500 RPM. You have to rotate above 1500 RPM to generate the power from the wind, right? Yes, so when we talk about the variable speed generators, just we can say you can use the variable power electronic converters we are connecting between the machines. So normally in the wind energy conversion system, we will use permanent magnet synchronous machines, slip ring machines, slip ring induction machines, and the spool cage induction machines, right? So these three machines are very popular in wind turbines. So based on the machine which you are choosing, only you are connecting the rotor, you are aware of it, only in the rotor you are handling only the slip power. So only 30% of the machine rating you are using here in the rotors, right? So that's the advantage of this two machines. As you are student, so I don't want to jump deep into the converter topologies. So just I am giving only the qualitative approach now. So when we talk about the PV, photovoltaic systems, so what are the power electronic converters you are connecting? So if I say it's a module converter, that is a very less power you are using this type of converters. Either you can use a single converter DC to AC and you are connecting the panel directly to the inverter and you are feeding into the grid. But here in this, you are having the DC to DC converter between the inverter and panel, and you are, so this will be called as a module inverter. Then DC form DC grid and you have a central inverter, but connecting the PV panels through the DC to DC converter. So maximum power point tracking and the other power conditioning will happen in this DC to DC converters. So this grid tied inverter only taken care of the injection of the power into the grid. And here central inverters for high power or if you are saying PV power plants, normally you will use this type of connection. See, here the central that can feed up more than 30 kilowatt of the power to the grid. So that's what we can say when we talk about the power electronics. The electronics, how it's having the major impact on the energy harvesting in the wind and photovoltaic systems. You can see that different types of converter ratings. We can see that the IT and consumers, just we can say so 1 to 5 kilowatt we are using here. For automotive, that means EV and all is coming up. Earlier people used to say that the car or bike or it's mechanical engineering, right? Mechanical engineer, or they will say it's automobile engineers. But nowadays the car is not, it's automobile engineer. So who is working on that car industry? Even the design and also okay, people have the mechanical engineering. But inside of it, earlier the heart of that car is your IC. Whether you are using engine, the EV is coming up. So in EV systems, embedded coding, then electrical engineer working on designing of the inverter and motors, and there is no IC engine. So here in the future, after 50 years, people used to say that the car is not a, even the electrical engineering side is one of the software product. Why? What's the reason? If the driverless, right? So playing computer vision playing the major role. So just we are deploying the more number of sensors on the vehicle. Even without the driver, your vehicle can take you. Even the driverless taxis are running in the US, right? So that's what you can say in the future. Your car also is going to be a software product, right? So there is a more software coming to your car. So that's what we can say, that electronics also plays a huge role in the drive, power electronic drives, UPS, even the transportation sector. Everywhere the power electronics plays a huge role. So in this, nowadays people are using a wide bandgap devices. So even the gallium nitrate or silicon carbide devices are using. Earlier people have used the silicon based devices, but now we are moving to the wide bandgap devices. That's a silicon carbide, SiCR GaN device. Doing this to reduce the. So if you are reducing the size of the converter, you can able to reduce the size of the system. Whether you can reduce the size of the vehicle or you can reduce the size of the any system. Right? So that's what we can say. Gallium nitrate and silicon carbide devices playing the huge role in the power electronics market. Yeah, next is fuel cell system. How you can generate the power from the hydrogen. That means you might have here that the vehicle is running with the water, right? So it's not running with the water means it's not having the IC engine. There you are having the fuel cell system. You are having the fuel cell system. So in a fuel cell system, what you are doing is you are having the water. From the water, you are separating the hydrogen by using the electrolyzer. So separating the hydrogen from the water, then you are storing that hydrogen. That feed into that. So this fuel convert the hydrogen energy into electrical energy. Even that in the exhaust pipe, you will get the water instead of the smoke, right? So because your hydrogen and it react with the water, and you will get the water output and the electrical energy in the fuel cell stack. That's a DC power. That DC power you are converting into DC, then DC into AC, then you are driving your vehicle, or again you are feeding the power into the grid. So this is what is the fuel cell power. And here another thing also is the electronics. In your theme, you are having a future electronics. So when we talk about the future electronics, IoT plays a huge role in the houses and buildings. That's what people are talking about: home energy management system and building energy management system. Even earlier, when you used to have the wristwatch is only to look at the time. But now you are using the wristwatch for measuring your oxygen level, your heartbeat and everything. That will be again connected to your mobile phone, right? So earlier, that's what that also is. We can say is a wearables. When we talk about the wearables, that smartwatches or smart healthcare devices also is playing the huge role, right? So that's what the IoT also is getting popular in these areas. So even if you talk about the connected cars, you are using the separate protocols for connecting the car. Even now, just we can say is a connected car. What does it mean? If they have OEM cars, we can able to interconnect it. That's what the connected cars. So that's what the IoT plays a huge role in these areas. I think I can stop at this point. If you have any questions, you can. Some companies, they are providing that net metering, but you will not able to connect to the internet. So only that EV persons can come and read that. Stop the plant because we are not okay with that. The cost of that meter also is huge. Then they need even the EVs running out of money. Yes. So they could not able to implement with the larger size. Yes. Any questions? Any questions? If you have any questions on discussion. Yes. Any question on the EV or IoT? Yes, no questions. I can this. Need to discuss anything, then we can drop me a mail, so I'll be available to discuss anything further. Right? Okay.
So thank you, sir. So Dr. Vijay Kumar sir has told about everything about wind energy, solar energy, smart grids. So it's really an eye-opening for all the young engineers in the electrical field. So though they are studying power electronics for renewable energy system, power system operation control. So sir has given a lesson is going history. So it is super, sir. Definitely it will give a lot of exposure to not only for the student, for the staff members also. So we want continuous seminar like this in our college. Thank you for coming from long away from Chennai to here, sir. Thank you, sir. Students, please sit down.
Time.
சுத்தி காட்டுவாரு.
அடுத்ததாடா இது அப்புறம் இன்னொன்று முடிஞ்சிருச்சா ஆஃப் பண்ணிட்டீங்களா
அப்படியா?